Welcome. Yeah, so now that I've taught you a nice little property of Laplace transforms, which is the fact that L of t times f of t is equal to negative capital F prime of s, we can very easily find the Laplace transform for the two functions t times sine at and t times cosine at, because notice both of these functions can be written as t times f of t in both instances, right? And we've already done the Laplace transform for sine at and cosine at, so f of t is sine at in this case, in this formula, and then f of t is cosine at in this case. And notice that this formula here tells us that the transform of t times f of t depends only on the transform of f of t. Specifically, the transform of t times f of t is equal to the negative of the derivative of the transform of just f of t. Now, let me remind you that from our previous work, we had found out that the Laplace transform, and I'll just write it here, Laplace transform of sine at is equal to, it's equal to a divided by s squared plus a squared, and then the transform for cosine at we wrote was equal to s divided by s squared plus a squared. So then the Laplace transform for t times sine at is going to equal, the negative of the derivative of the transform for sine at, because that's f of t in this instance, right? So the transform for sine at was a divided by s squared plus a squared. And so my next line, I'll write that what we have is the same as the negative of the derivative with respect to s of, well, I'm going to rewrite this so that it's easier to take the derivative of it. And that says a times s squared plus a squared to the negative 1 power. That way, I'll just use the power rule and chain rule and avoid the quotient rule, right? Okay, cool. So I'll have that Laplace transform of t times sine at is equal to, that'll work fine, is equal to, well, the negative of, what's the derivative here? Negative 1 times a is negative a, so negative a, and then times, it's going to be s squared plus a squared. Got to decrease the power by 1, so negative 2 power. And then by chain rule, we need to multiply by the derivative of s squared plus a squared, which is just 2s, since a is a constant, and therefore a squared is a constant. Yeah? Okay, cool. All right. So then we have L of t sine at is equal to, what is this? Negative is positive. A times 2s is 2as divided by, I'm going to put this downstairs with a positive exponent, divided by s squared plus a squared all squared. And this is it. And do I really have to do t times cosine at now? Hopefully not. Hope you're satisfied. Otherwise, just mimic my steps here, yeah? Okay, I'm done here.